Hey guys, Mr. Backwork here. In this video, we're going to write equations and inequalities. So an equation is a mathematical sentence that's formed by placing an equals sign between two expressions. And as far as an inequality goes, an inequality is a mathematical sentence formed by placing one of these symbols between two expressions. And on the next slide, we're going to talk about what each one of these symbols means. Now, as we start taking a look at some of these symbols, the first one we've got is an equal sign. So that just means that two expressions are exactly equal to each other. Now, as we're translating verbal phrases into equations, things that we need to be on the lookout for are things like saying something is the same as, or even just the word is going to mean that we have an equal sign happening. Moving down to our next symbol, we've got this arrow pointing to the left, and that's our less than symbol. And that just means that the expression on the left-hand side is smaller than the expression on the right-hand side. Now, as we're looking at translating things, also saying that something is fewer than would be a good indication that we've got this less than inequality happening. Now, we could also put a line underneath that inequality symbol, and that changes the meaning just a little bit. So it changes it from just being strictly less than, like we saw directly above, but as soon as we put that line underneath it, it means that it's less than or equal to. Now, some other words that we see associated with this less than or equal to symbol, we could say at most, or we could say is no more than. Now, if we flip that arrow so that it's pointing the other way, that's our greater than symbol. So it's going to mean that the expression on the left-hand side is bigger than the expression on the right-hand side. Or we could also say that it's more than. And again, putting that line underneath changes that inequality symbol just a little bit. So now instead of just being greater than, now it's greater than or equal to. Or we could also say it is at least or no less than. Now, what we're going to work on doing here is taking some verbal expressions and translating them into either an equation with an equal sign in there or an inequality with one of those four different inequality symbols. So in this first example, it says the sum of twice a number r and 3 is 11. So we have to think about different keywords that we've learned. There are operational keywords that tell us that we have a specific math operation happening. And now there's also these new keywords that tell us if we need to put an equal sign or a less than or a greater than or equal to or some sort of other inequality symbol. So the first thing I see is the word sum. And the word sum means that we've got addition happening. Now, what are we supposed to add together? Well, the first thing I see is twice a number r. And twice means we're going to do a little multiplying. Specifically, we're going to be multiplying by 2. So twice a number r means that we're going to have 2 times that r value. And we're supposed to add 3 to that. So we've got 2r plus 3. Now we've got this word is. And is was one of our keywords for an equal sign. So is means equals, and then we've got this 11. So we can translate that verbal phrase into the equation 2r plus 3 equals 11. Now in this next one, we've got the quotient of a number n and 2 is at most 16. So again, we're looking for keywords, and the first keyword that I see is quotient. And quotient means we're going to be doing some dividing. I like to write my division problems as a fraction. So quotient means that I'm going to make this fraction bar. I'm going to put this n on top since it comes first, and I'm going to put this 2 on bottom since it comes second. Now, as far as our symbol that we're going to put in here, we're looking at that is at most. And those are some of our keywords for a less than or equal to symbol. And then we've got 16. So we get n over 2, or n divided by 2, is less than or equal to 16. Now this next example has a lot going on. So we've got the product of 5 and the quantity 3 more than a number w is at least 12. So the first thing I see is we've got a product, which means we're going to be doing some multiplying. And I'm supposed to take 5 times some quantity. So what that quantity means, remember, that means we've got a set of parentheses. And if we're multiplying this 5 times this set of parentheses, then we're just going to put that 5 on the outside. It's not necessary to put that multiplication dot in there because just writing these right next to each other means that we've got multiplication happening. Now, as far as that quantity, it says that we're supposed to take 3 more than a number w. And more than, those were keywords for addition. So 3 more than w means 3 plus w. Now we've got this is at least, and those were some keywords that meant greater than or equal to, and then we've got our 12. So we've got 5 times this set of parentheses with the 3 plus w inside of it is greater than or equal to 12. Now the next thing we're going to be working on here is checking whether a given number is a solution to an equation or an inequality. Now what that means we're going to do is we're going to take whatever number we're given and we're going to plug it in for our variable in our equation or in our inequality, and we want to test out to see if that number makes this equation or inequality true. If it does, then we would say yes, it is a solution, but if it doesn't, then we would say no, it's not a solution. So here we're supposed to look at the equation 24 minus 3d equals 9. And they're asking us to test out if 5 is a solution. So I need to take that 5 and plug it in for d. So we would get 24 minus 3 times 5 equals 9. Now we're going to simplify down the left-hand side, and we're going to see if that does in fact equal 9. Order of operation says I need to take care of this multiplication first. So 3 times 5 is going to be 15. So we get 24 minus 15 equals 9. Now we still have subtraction to take care of on the left-hand side. So we're taking 24 minus 15. And if we do 24 minus 15, we get 9. So 9 equals 9. Now in an equation, what we're hoping for is to have the same exact number on the left and right side. Here we do, so we would say yes, 5 is a solution for our equation. Now in this next one, we're dealing with an inequality. So you've got 3x plus 4 is less than 18, and we're supposed to test out the number 6. So we're going to take that 6 and we're going to plug it in for our x. So we would get 3 times that 6 plus 4 is less than 18. And again, we're going to simplify down the left-hand side to see if it makes this true or not. So 3 times 6 is going to give me 18, plus 4 is less than 18. Now if we take care of that addition on the left-hand side, 18 plus 4 is 22. So now we have to think to ourselves, is 22 less than 18? And the answer is no. So we would say no, this one is not a solution. Just a couple more examples of checking whether numbers are solutions. So we've got 8c is greater than or equal to 32, and we're supposed to test out 4. So the very first thing I'm going to do is plug in that 4. So 8 times 4 is greater than or equal to 32. So now we need to simplify down the left-hand side. So we're taking 8 times 4, and 8 times 4 is 32. So now we need to think to ourselves, is 32 greater than or equal to 32? Well, first let's think about this. Is 32 greater than 32? No, it's not. But this has that equals to line. It has that extra line underneath there. So it's okay for these numbers to be exactly the same. 32 is equal to 32. So yes, 4 is a solution. In our last example here, we've got a minus 6 is less than 3, and we're supposed to plug in 8. So this is going to say 8 minus 6 is less than 3. If we simplify down the left-hand side, 8 minus 6 is 2, so we've got 2 is less than 3, and we have to think to ourselves, is 2 less than 3? And the answer is, yes it is. So 8 is a solution for this inequality. That's going to be it for this video. Thanks for watching.